Okay, in 4-1 we're going to identify linear functions. Alright, on the first one we're going to identify whether each graph represents a function and explain if the graph does represent a function, is the function linear. Well, one of the things we want to do is use the vertical line test. Remember, you're going to draw a line, and if you notice here, when I draw a vertical line on that graph, it touches in many points. Therefore, it does not pass the vertical line test. Therefore, it is not a function. So because it is not a function, I can stop right there. It is linear. You can see that it is a straight line, but it is not a function. On number 2, when I draw a vertical line at various points, notice it only crosses one time at each one of those markings. So it is a function. However, we can clearly see it is not linear because it has that angle to it. So it is a function, but not linear. So what would make a linear function? Well, if you were to have a graph that would go, say, this way, and if you did obviously that's linear, but if you did the vertical line test, it would only touch once, and once again, and it is linear. It would have the same slope consistently. Therefore, this would be a linear function. In this part, it says which of these sets of ordered pairs satisfies a linear function. So in order to satisfy a linear function, that means the rate of change has to be the same. So what I'm going to do is I'm going to take each one of these and I'm going to put them in a table. So -10, -9.9, -9.8, -9.7. Then the accompanying number is 3, 4.5, 6, and 7.5. Now, as you can see, I have here's A and here's B. I've put them in vertical tables. What I'm going to check, I'm going to check the ratio. Now remember, change of x. When we go from -10 to a -9.9, that means we're getting greater. So that's plus 0.1. Again, from -9.9 to 9.8, again that's plus 0.1. And the same for -9.7, that's again plus 0.1. Then when I go to 3 to 4.5, that is plus 1.5. Okay. When I go to 4.5 to 6, plus 1.5. And when I go from 6 to 7, it's plus 1.5. Now, when I say take the ratio, you take the change in x over the change in y. So the change in change in y over change in x. So if you notice, they're all three the change in y over your change in x would be 1.5 over 0.1, and they're all three the same. So if you notice right here, 1.5 over 0.1, 1.5 over 0.1. Remember, this is your change in y, this is your change in x. And you notice all three ratios are the same, therefore that is a linear function. Now, on part B, what we can see is these increase by 1, increase by 2, increase by 4, and they increase by 8. Over here, these all consistently increase by 5. Now, if I were to look at the ratios, I get change in y over change in x. So the first one would be 5 over 1. The second one would be 5 over 2. The third one would be a change of 5 over 4. And then the last one would be 5 over 8. Now, in order for this to be linear, these all four would have to be equal, and as you can tell, none of them are equal. Therefore, it is not a linear function. In this particular problem, we want to take y equals -x plus 3, and we want to convert it to standard form. Remember, standard form is ax plus by equals c. Now notice that means the x and y are on the same side. The a, the b, and the c all stand for numbers. So in order for me to move this x over here to be with the y, I need to add x to both sides. So now on this side you're going to have a positive x. The y is plus y. This is probably the hardest concept, trying to put those together. Remember, it's not xy. You're combining them on the same side, so it's a positive x and a positive y. The x's cancel out here, and you're left with bring down the 3. Notice, in this case, you have ax plus by equals c. Your a is going to be an understood 1. The b is an understood 1, and in this case, your c is a 3. Now, one of two things we can do. We can use the cover-up method, or we can just use y equals negative x plus 3 from the graph that or the equation we had before. Now, what I'm going to do is I'm going to do my intercepts. So I'm going to plug in when x is 0, all right, y has to be 3. So that means when x is 0, y has to be 3. So at 0, 3, I'm going to pull out a point. Then I'm going to plug in at 0 for x, or sorry, for y. So when y is 0, I need to find x. So this cancels out, so you end up with x equals 3. So when y is 0, x is also 3. So at 3, 0, right here. Now, when it says graph the function, I can simply draw a line straight through those 2 points, and there's my graph. Okay, in this particular problem, a campground charges $30 for 2 people, plus $4 for each additional person. Okay, that's good to know. Now the amount of total owed, or the total amount owed, is given by the function f of x equals 30 plus 4x. This is the $30 for the 2 people, and then the $4 for every additional person. So we're going to use that in order to complete the graph. Now it says also to graph this function and give its domain and range. Well, first of all, if 0 people go, it's still going to cost $30 because you have to prepay in order to reserve a camping ground. So if I were to do this right here and I plug in an x, all right, here's my f of x. Remember, f of x is another name for y. So if I plug in 0, that means I'm plugging in 0 right there. So 4 times 0 is 0, plus 30 is 30. So with 0 people going, it's going to cost me 30 bucks. Now, if one additional person goes, sorry, that means additional person. So how many additional people? Remember, if 0 additional people going, that actually means 2 people. All right, so if one additional person goes, that's going to be $4 more, so that's going to be $34. If 2 more people go, that's going to be 4 times 2, which is 8, plus 30, so that's 38. Well, let's think about it. How many people can go to a campground? Well, if you're going to have a big cookout or so forth, you might have up to 10 people. Well, again, if I have three additional people, that's 12. So 12 plus 30 is 42. So again, notice we're adding 4 each time. Now let's skip down. Let's say 10 people, because it is possible we have 10 people. Well, then you would have 30 plus $4 for the 10 additional people, which would be 40. That would give me a total of $70. Well, looking at the graph, these are additional people versus amount. Now notice it goes by 10, 20, 30, 40. So this means 0 here. So at 0 additional people, so at 0 additional people, let me erase that real quick. It's going to cost $30. So we're starting right there. Then for one person, it'll cost 34, so we'll put an estimate right there. For 2 additional people, it's going to be about 38, so about in the middle. And then finally, as you notice, for 3 additional people, it'll go up to 42. So notice how it's pretty linear right here. And if I go all the way up to 10 people, that's going to be about 70, so it's going to be about right there. Now, if you notice, that's a pretty straight line. So I'm going to take this marker, and I'm going to try to draw the best line I can. And with this line, I can use this as a prediction to predict approximately how much it would cost. So 6 people, you could see, would probably cost around $54, somewhere around there. Okay. So my domain in this case, my domain would be anywhere between, I'd say 0 to 10 additional people. So 0 is less than or equal to x, which is less than or equal to, let's say 10 is the most. We're going to cap it out. My range, well, remember my range starts here. Well, we're going to start at $30, but then my range can go all the way up to, let's say, $70 in this case. If we keep it at 10 people or 10 additional people. So that would be my domain and range.